Hi, this is Barry Mednick for Stephen Academy, AP Statistics. We're going to continue looking at the AP Statistics exams from previous years. Today we're going to look at free response questions, and also for the next few sessions. Okay, so the first question, a simple random sample of 100 high school seniors was selected from a large school district. The gender of each student was recorded, and each student was asked the following questions. 1, have you ever had a part-time job? And number 2, if you answered yes to the previous question, was your part-time job in the summer only? And we ended up with some numbers. Male, female, never had a part-time job. That's just the total over there. Summer only. And had a part-time job outside of the summer as well. So we have a total of 48 males and 52 females. So first of all, you're asked to construct a graph, and you're given an empty space in which to put in that graph. Now, when you do a graph on the free response questions, you want to make sure everything is very clear. Don't assume that the readers, who are in fact experts, usually teachers of statistics or at the very least graduate students of statistics, don't assume that they know what you're doing, because you are graded on how well you explain things, not just how well you actually do the formulas, but how well you justify what you've done. So you want to explain what you used and why you used it. So you're given a graph. Now, what would be the best way to express these things? We could show a line graph, but the fact of the matter is that's not going to demonstrate this very well. And what you're being asked to do is construct the appropriate graph. That's what you're being tested on. We have two variables here, male and female, different categories. So line graphs are more when the x-axis is time. The x-axis is not time here. So what we want to use are bar graphs. So you want to set up a bar graph and label your axes, right? Number of respondents, something like that. And make it clear what the y values are, that they go from 0 up to some number greater than 30. And you'd have bar graphs here. And one of these would be for male and one for female, and we want to differentiate here, and you'd have to have a legend that says the one with the stripes is female and the plain one is male, and we'd have bars for each of these. And then here we would say never, or never had a summer job, or make it very clear what you're doing and why you're doing it, and put a little note there that a bar graph demonstrates this better than any other kind of graph. The second part of this is write a few sentences summarizing what the display reveals about the association between gender and job experience. Okay, they're just asking you to analyze this information. So when it says write, they mean write in English in full sentences. The females were more likely to never had a job. Females were less likely to have had a part-time job during the summer only. Say, look, if there were no association between these variables, we'd expect the numbers to be about equal. But in fact, we see differences in the bars. Therefore, there appears to be association between job experience and gender. You want to say this. The last question says, which test of significance should be used to test if there is an association between gender and job experience for the population of high school seniors in the district? State the null and alternative hypotheses, but do not perform the test. Okay, so what type of test? Well, we don't have a standard deviation here. We're not looking for the mean of a population. We're comparing two sets of numbers to each other. So the appropriate test is the chi-squared test of association. When you're comparing two sets of numbers like this, you should see the chi-squared test because that associates one group of numbers with another. And your hypotheses, H0, there is no association between gender and job experience. H1, there is an association between gender and job experience. Or you could have said gender and job experience are independent, and H1 or HA, the alternative hypothesis, gender and job experience are not independent. So that would be the answer to that type of question. Okay, the next question involves a tire manufacturer designed a new tread pattern for all-weather tires. Repeated tests were conducted on cars of approximately the same weight traveling 60 miles per hour. The tests show that the new tread pattern enables the cars to stop completely in an average distance of 125 feet with a standard deviation of 6.5 feet. Okay, so we have a mean and a standard deviation. And that the stopping distances are approximately normally distributed. So the first question is, what is the 70th percentile? Okay, so the intent of this question is to see if you know how to use the z-table for a normal distribution. The 70th percentile means means the probability is 0.7. So you have to ask yourself what z-value is associated with 0.7, a probability of 0.7. So if you look up in the normal table, which you were given, the standard normal table, you find that a probability of 0.7 corresponds to a z-value of 0.525. That's 0.525 standard deviations above normal, because 0.7 is above normal. Normal would be 0.5, the mean. The next question is, what is the probability? Oh, excuse me. And they ask, what is the 70th percentile of the distribution of stopping distances? So we have to figure out what stopping distance corresponds to this. Well, the value there is mu plus z times sigma. So that would be 125 plus z, 0.525, times the standard deviation, which is 6.5. When we multiply that out, we get 128.4 feet. So the answer to the first part of the question is 128.4. Don't just write 128.4 on the answer sheet. Show your calculation. Show the formula. Put everything down on the paper. Don't leave any possibility for the grader to question how you came about with this number. Show every step of the way. Okay, so question B. What is the probability that at least 2 cars out of 5 randomly selected in the study will stop at a distance that is greater than that distance from part A? Well, it doesn't really matter. You could have gotten part A wrong. You can still calculate this. Let's think about this. 2 out of 5. We have 5 cars we're going to test, and we want to see that the probability that 2 of them will stop at a distance greater than this. Well, that's a binomial distribution. Success in this case is a car going beyond this distance. Now, the driver might not consider that success, but that's what the problem is defined as success. So you have to say this is a binomial distribution. And the binomial distribution, you're not given the binomial table. You are given the binomial formula, which is the combination of n things taken x at a time, p to the x, q to the n, that should be n, q to the n minus x. So the probability that, this would be the probability that exactly 2. Now the question, note the wording of the question, that at least 2 cars. So we would have to calculate for 2, 3, 4, or 5. It's easier to calculate 0.